Hi everybody, welcome to another video in Pre-Calculus, section 6.1 and 6.2, inverse trigonometric functions. So before we go to inverse trigonometric function, here what we need to know about inverse functions. So first of all, if a function is one-to-one, then it has an inverse. So only one-to-one function has inverse. The first one. Next, the domain of the function is the range of the inverse, and the domain of the inverse is the range of the function. So from the function to the inverse, and from the inverse to the function, we interchange the domain and range. And the combination of the function and the inverse is equal to x, where x is in the domain of the function and in the inverse, respectively, for each one of them. The graph of the function and inverse are symmetric with respect to the line y equal to x. Right, so that's what we have about inverse. Now, we go to trigonometric function. Now, what we learned on the previous chapter is that all trigonometric functions are periodic, meaning that the function, the values of the function will be repeated after some period. And we have just a quick review. Sine, cosine, secant, cosecant, the periods are 2 pi's. Tangent and cotangent has period of a pi. Alright, now, if it is a periodic function, it cannot be one-to-one, because if the y value is repeated for different values of x, it cannot be one-to-one. So if it is not one-to-one, it cannot be an inverse. So in that case, we have to restrict the function so that we have a one-to-one function. Right. So if we graph the function y equal to sine x, y equal to sine x, it is not one-to-one. So we have to pick a domain so that the function is one-to-one, and the domain that we pick is, first of all, from 0 to pi. Always we will pick the quadrant 1, and then we have a choice. If we're going to pick this one, it is not going to be one-to-one, because on the y values from 0 to 1 here, we have to choose a different region. We could choose this part here, or we choose this part here. Actually, we're going to choose this, because the function will be continuous. And from 0 to pi over 2, that is quadrant 1. And from negative pi over 2 to 0, well, that is in quadrant 4. From 0 to pi over 2, that quadrant 1. And from negative pi over 2 to 0, that in quadrant 4. Right. So if we restrict the domain from the function from negative pi over 2 to pi over 2, or in quadrant 4 and quadrant 1, in that case, the function is one-to-one. This part of the function is one-to-one. If it is one-to-one, it will have an inverse. So we define inverse of sine y equal to inverse of sine of x, means x equal to sine y. So pretty much we interchange x and y, interchange the domain and range. Right, now we have the graph here. Kind of difficult to see, but this is the graph of the function. Y equal to sine x, and this will be the graph of the inverse. Of course, they are symmetric on the line y equal to x. Yeah, that's it. Y cosine inverse of x. Right, the symmetric on the line y equal to x. So first, in the function y equal to sine x, we restrict the domain from, the domain will be from negative pi over 2 to pi over 2. And the range will be from negative 1 to 1. And then all we need to do is just switch them negative 1 to 1 for the domain of the inverse, and negative pi over 2 to pi over 2 for the range. So this is the function. The domain is restricted from negative pi over 2 to pi over 2. And the range from negative 1 to 1. Right, and then from the function to the inverse, the domain will become the range, and the range become the domain. Right, we just want to switch that. Right, next, find the exact values of sine inverse of negative 1. Well, this is the sine inverse of negative 1, that is pi over 2. By the way, if we going to use inverse, I recommend that we keep the calculator in degree mode. And then when we type sine inverse of negative 1, give us negative 90 degrees, or negative pi over 2. Actually, I forgot the negative, sorry. Yeah, so negative pi over 2. Yeah, this point. Right, now, remember the trig values function, we use the hand, right? So in that case, wherever the angle is, the possible values that we know, the nice value for sine, cosine, that have the nice angle is either 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2, which is 2 over 2 is 1, and this is 1/2. That is 0. So those are the special values of sine, cosine. When we see these values, we should get the exact values. If we have like 1 over 3, then we just use a calculator to estimate. So we only know the values, the trigonometric function values of this. So when we have these values, we know that it's going to come up with the nice angle. Then the angle will be of these values. Right, now the square root of 3 over 2 is one of those values, so we know that the answer is going to come out something nice and even. Square root of 3 over 2, that is 60 degrees. We can use degrees, or we can use pi over 3. Of course, now we just look at this, right? Square root of 3 over 2. Remember, sine is the number, square root of the number of fingers on the right divided by 2. So there will be 3 fingers on the right. Square root of that divided by 2, right? The angle is pi over 3. If it's negative, it will be negative, right? Now, let's try it. If we have, let's say, sine inverse of negative square root of 2 over 2. Well, we have square root of 2 over 2, meaning that 2 fingers on the right, square root of 2 over 2, and the angle is pi over 4. However, this is negative. So, yeah, negative. Right, so it's easy enough. Now, when we have some other values than the values we know, if we have the special values, those are the values we know the angles. If we have something else, we just need to use a calculator to approximate this one in radians. So make sure we keep the calculator in the right mode. Sine inverse of 1/3. So yeah, just get approximation of 0.339a. And negative 1/4 also is not a nice values. Yeah, these are the nice values. Negative 0.2527, let's say. Right. Next, recall that for the domain from negative pi/2 to pi/2, the function is 1 to 1, and the range is negative 1 to 1. So the composition of the function and the inverse will be itself, meaning that sine of sine inverse and sine inverse of sine of x, both of them equal to x. But it has to be in the domain of the function and domain of the inverse. Right, let's look at this. Sine pi/9 and sine of inverse of sine of pi/9. So we look at the first one. Is pi/9 between negative pi/2 and pi/2? So in that case, I just need to ask this question. Is pi/9 between negative pi/2 could be equal to and pi/2? And the answer to that, of course, it is, right? Pi/9 is between negative pi/2 and pi/2. So yes, if it is in the domain, then it will be equal to pi/9. So if the angle is between this interval, the sine and sine inverse pretty much cancel out, and that's what we have. Right, next, sine and sine inverse of negative 2. Well, of course, we look at this, and negative 2 is not between negative 2 and 2. So first thing we check is the negative 2 between 1 and negative 1. And the answer is that is no. So in which case it will not cancel out. But what's that really equal to? Let's just put in the calculator. By the way, let's keep in radian by default. Yep. Right. Sine of sine inverse of negative 2. Okay, there's some error about this. So what's wrong here? Sine inverse of negative 2. Sine inverse of negative 2. Now, that is the problem in the domain. Because when sine x, sine inverse of x, whatever the numbers here, it has to be between negative 1 and 1. So we just say that sine inverse of negative 2 is undefined. So the whole thing is undefined. Right. The next one is more interesting. First, let's check. Is the domain here is 5 pi/3 between pi/2, between negative pi/2 and pi/2? That is the question. And the answer to that is, of course, no. 5 pi/3 is bigger than pi, therefore bigger than pi/2. So it's no. So if it is not, then we know that the answer is not going to be 5 pi/3. If it is, in this domain, then it will cancel out, but it's not. So let's see if we can answer this. Sine of, let's do sine inverse of sine of 5 pi over 3. Right, what's that? Right. Now, think about this. Let's just draw the values. Draw a circle. Let's do it here. Five pi over 3. Where is that? Five divided by 3 is about 1.66. So we talk about 5 pi over 3 is about here. So that is the angle of 5 pi over 3. Right. I think the calculator has a problem. It has to have to reset everything. Right. So 5 pi over 3 is that. Now notice that whatever the answer is, it has to be between negative pi over 2 and pi over 2, right? Because in the sine inverse, the answer should be negative pi over 2 to pi over 2. So we have to convert whatever this point is between negative pi over 2 to pi over 2. Well, if we want to pick the values, it's going to be negative pi over 3. So whatever the answer here, when the sine inverse of sine, the answer has to be between, doesn't matter what it is inside though. Doesn't matter what it is inside. Sine inverse of something has to be between negative pi over 2 and pi over 2, 1 and 4 and 1 and 2. So in that case, we have to choose the equivalent values, which is negative pi over 3. And let's do this again in the radian mode. Sine inverse of sine of 5 pi over 3. So we have that, and then negative pi over 3. Yeah, it should be the same. So whatever the answer in this one is, it has to be between negative pi over 2 to pi over 2. Right. Next, sine of sine inverse of 1/3. We'll check is the 1/3 between negative 1 and 1. The answer is yes. So in that case, it's equal to 1/3. Now, like I said, if it is in the correct domain, it will cancel. If it's not, then the answer is they not cancel and they equal to something else. Right. Now the important note here is when we write a sine inverse of sine of something whatever it is, the answer have to be between negative pi over 2 and pi over 2. But regardless, doesn't matter what we put in there, it is always defined. And now, if we have the other way around, where we have the sine and the sine inverse of something, well, now it will cancel out if that value is between -1 and 1. So I say this one is equal to square if whatever it is between -1 and 1 or even better, we write sine of sine inverse equal to that. Even the stronger statement is it will be the case if it exists. Meaning that the inside has to be exist. If you put something, of course we can also write from -1 and 1, that is more precise statement, but in more general, sine and sine inverse will cancel out if it exists. Sine inverse of sine between -pi/2 and pi/2, but it is always defined. Right? So think about this way. I summarize it as follows. Sine and sine inverse exist, then they will cancel out. Sine inverse and sine may not cancel out, but it always exists. So one always exists, always defined, but may not cancel. The other ones, if exists, will cancel. If not exists, of course, they cannot cancel out anything. So that's summarized in this part here. Of course, when we go to cosine and tangent, of course, they will repeat these properties. Right, talking of which, we go to cosine. Right, cosine function go like this, but we have to restrict the domain so that it will be 1 to 1. So once again, we're going to pick the quadrant 1. And then we have, if we choose this quadrant 4, it will not be 1 to 1. So we have to choose the graph so that the y values will be new. So we choose quadrant 2. So from 0 to pi. So I will write down for y equal to cosine of x. The domain from 0 to pi. The range from -1 to 1. Of course, the domain, the cosine of x in general, is all real numbers, but we restrict this so it will be 1 to 1. So we have y equal to cosine of x. Of course, that function is 1 to 1, and only 1 to 1 function has inverse. Right, so we have y equal to cosine of x. Talking about this one. And this will be the inverse. Of course, in the inverse function, we just need to switch the domain or range. So the domain for the inverse will be from -1 to 1, and a range from 0 to pi. Right? So we switch the domain and range of the function and the inverse. Straight from definition. Next, find the exact values if possible for cosine inverse of 1/2. Well, 1/2 is one of those special values, right? So 1/2 meaning what? Cosine is the number of fingers on the left. So 1/2, 1 fingers, angle is pi/3. So that is exactly pi/3. Of course, if we use the calculator for inverse, I recommend that it is in the degree mode when we use inverse. So I repeat, for inverse function, when we use the calculator, keep it in the degree mode. It will give us the exact values, 0.5 or 1/2, 60 degrees, which is pi over 3, right? Right, next, square root of 3 over 2. Well, negative square root of 3 over 2. So square root of 3 over 2, meaning that there are 3 fingers on the left, so that will be this one. And that is pi over 6. Not exactly pi over 6, but you get the idea there. Right, so in the unit circle, we know that square root of 3 over 2, that is where it is pi over 6. So when we have pi over 6, the value is negative square root of 3 over 2, which is cosine the x values here. Right, but this is negative, so it will be on the other side. So what is the other side here? Well, they're also over 6, because those are the reference angle. I mean, the pi over 6 is the reference angle of this, and we have to choose a number here, and that cannot be divided by 6, so cannot be 1, cannot be 2, because 2 and 6 can reduce, 3 over 6 can reduce, 3 over 6 can reduce, 4 over 6 also can reduce, only 5 pi over 6, only 5 and 6 are irreducible. So yeah, 5 pi over 6. The cosine inverse has to be between quadrant 0 and 1 and 2, between 0 and pi. Or we say cosine inverse of negative square root of 3 over 2. So 150 degrees, which is 5 pi over 6. And if we have cosine 3 over 5, those are not special values in this. Those are not, 3/5 is not one of those special values. So just get an estimate. Cosine inverse of 3/5. Make sure that we know what mode we are on. If it is the case, then it is about 53.13 degrees. Right, so now what we have, the next part is similar to what we have in the previous part of the section. The domain for 0 to pi, the cosine function is 1 to 1, therefore we have the inverse, and the range from negative 1 to 1. Right, so interchange the domain and range, interchange x and y. Because of that, the combination of the function and the inverse are equal to each other. So and the function. Right. Now I will write out the note before we actually do it, compared to the previous section. This will be true for only trig function. Actually, this will be true for sine cosine function. So here goes. We have cosine inverse cosine of something. The answer, cosine inverse of something, doesn't matter what it is. It has to be between negative, in quadrant 1 and 2, meaning between 0 and pi. It's always defined. But, so, the inverse will cancel the function. If, the answer of the sine inverse and sine always between negative pi over 2 and pi over 2. The answer here, the answers have to be between 0 and pi. But the other way around, when we have cosine and the cosine inverse, it will cancel. They cancel out if it is defined. Of course, if it is not the number between negative 1 and 1, it is undefined. and therefore it cannot be cancelled. Right. Now it's easy. Now we look at this. Cosine inverse of cosine pi over 15. Well, pi over 15 is between 0 and pi. So yes, that cancels out. Because pi 15 is between pi over 2, between 0 and pi, sorry. Yeah. Negative pi over 2 and pi over 2 is for sine. This is for cosine, so 0 and pi. Yeah, that works. Now, next, this one we know it is not going to be equal to negative 3 pi over 4. Why? Because negative 3 pi over 4 is not between 0 and pi. So just put a box here, and it's not true. Because the values is not between 0 and pi, they will not cancel out. It will cancel out if it is between 0 and pi. Now, we know the answer has to be between 0 and pi. So let's try to write where's negative 3 pi over 4. Negative 3 pi over 4 be negative 3 pi over 4. That will be that. Now, the answer, when doesn't matter what we have inside here, when we have cosine inverse, it has to be between 0 and pi. That's one for sure. Just like this, if it is between 0 and pi, that's good. If it is not, the answer still has to be between 0 and pi. So what do we choose the angle so that it will be the same as this? Now notice that, remember, cosine is the x values, right? So we have to choose the one that have the same x values. So the answer have to be whatever this angle is. Well, they both divide by 4, and this one is clockwise is negative, counterclockwise positive. That will be 3 pi over 4. So that will be 3 pi over 4. So what we see is that when we have the cosine inverse of cosine of something, the answer is always between 0 and pi. So we have to draw it out and find the equivalent values for it. But if it is between 0 and pi already, they're just going to cancel out. If we have the cosine inverse, just determine if it is defined or not. So for example, if I ask you what is cosine of the cosine inverse of 2/5, well, if it is defined, then that will cancel out. You see. Yeah, that's 2/5, right? Yeah, so we'll cancel if it is defined. Now, if it is not defined, when we have something like cosine inverse of 2, it's undefined. Well, if it is the function, the cosine inverse will cancel out if it is defined. The cosine inverse and cosine may not cancel out. It is always defined though. But we know the answer has to be between 0 and pi. So try to draw the comparison of this sine inverse with the cosine inverse. Right. Now we go to inverse tangent function. So tangent, the graph of tangent is like that. Once again, it's not 1-to-1. If we want it to be 1-to-1, we have to restrict the domain, so it will be 1-to-1. Right. So we will pick this part of the graph. and when we have y equal to tangent of x, if we want it to be 1 to 1, the domain has to be between negative pi over 2 and pi over 2. Notice that this is not the bracket, this is the parentheses. This not including the pi over 2 and negative pi over 2, which are the asymptotes. And then the range of negative infinity to infinity. Right. So in that case, we have the tangent is here. And the inverse. And all we do, we just switch in the domain and range. Domain will be negative infinity to infinity, and the range for that function negative pi over 2 to pi over 2. Right. So just exactly like what we have for the sine and cosine inverse, we want to restrict the domain and range, so that is 1 to 1, and after that interchange the domain and range. Then we have the inverse function. Right. Now, recognize some special values of sine, cosine. 0, those are the special values: 0, 1/2, square root 2 over 2, square root 3 over 2, and 1. So what are the special values for tangent and cotangent? For tangent and cotangent, the special values will be, if we use the right hand rule, square root of the fingers on the right divided by square root of fingers on the left. So the special values will be 0, undefined, here we have 0 over square root of 4, or just 0. Here is square root of 1 over square root of 3, so 1 over square root of 3, and square root of 2 over square root of 2 is 1, and then square root of 3. So these are the special values for tangent and cotangent. When we see these values, we know that the tangent inverse will be equal to a nice values, nice angle. Right. So what is tangent inverse of square root 3 over 3? By the way, if you want to do the inverse, recommend that the calculator is in the degree mode. So tangent inverse of square root of 3 over 3, 30 degrees. Pi over 6. Right. By the way, for 1 over square root of 3, we can multiply square root of 3 top and bottom to have square root of 3 over 3. If we want to rationalize the denominator, we do that. But you should recognize the special values for sine or cosine, and special values for tangent or cotangent. This. Now, what is tangent inverse of negative 1? Well, so tangent inverse of negative 1, negative 45 degrees, negative pi over 4 radian. Right, simple enough. And just like what we have earlier, the tangent will cancel the tangent inverse whenever it is defined. But in this case, it is defined everywhere. So once again, the function cancel the inverse if it is defined. The inverse only cancel the function if it is in the domain. Right, so, but it's always defined on that case. I mean, if it is, within this, right? So whether we have, it doesn't matter what the trig function is, the function cancel the inverse if it is defined. The inverse cancel the function if it is in the domain, right? I speed that. I will repeat this. The function cancel the inverse if it is defined. The inverse only cancel the function when it is in the domain. This will be true for only 6 inverse trigonometric function. Right. Now we have more example. Find the inverse function of f of x equal to 2 sine x minus 1, right? Which the domain of this, of course, we still need the function to be 1 to 1. So let's write it out. The function 2 sine x minus 1. The domain of this is what? Negative pi over 2 to pi over 2. And then the range, don't know. Right. Actually, it is easy to determine, but we'll get back to that. Now to find the inverse, it's easy, right? Replace the function with y. So we have y equal to 2 sine x minus 1. Now to find the inverse, we interchange x, y. We have x equal to 2 sine y minus 1. And now we solve for y. So move the 1 over. We have x plus 1 equal to 2 sine y, and divide by 2. Right. If sine 1 is equal to that, then y will be equal to what? Sine inverse of x plus 1 over 2, right? Right. So interchange x and y, and then we just solve for y. Simple enough. Now we just need to determine what is the domain and range. Right. The domain and range. By the way, let me write out the inverse. Sine inverse Right. Now what is the domain and range? Right, so how do we determine that? Now if we know the domain and range of the function, then for the inverse we just interchange. Can we do that? The answer is yes. Remember, the sine x in general, what do we have? Between negative 1 and 1, right? The sine x, remember the graph, is between negative 1 and 1. Or the range of the sine x is negative 1 and 1, right? Now we can multiply by 2 on both sides. So I have negative 2 right? So just multiply everything by 2. That's what we have. And after that we subtract 1 everywhere. So that gives us negative 3 2 sine x minus 1 less than equal to. So the range for this function is between negative 3 and 1. So simple enough, right? We know sine is between negative 1 and 1, so that's why we can write like that. And we solve for the function 2 sine x minus 1, and that's what we had, what we end up with, that. Right, and so that is for the function inverse, which is interchange. In that case, the domain will be go to the range of the function -3 to -1, -3 to 1, and the range -π/2 to π/2. Just switching the domain and range from the function to the inverse. Right, next, try to solve this. Now to solve this, first I'm going to get the inverse function by itself. So why don't we divide by 12 on both sides. So we have sine inverse that gives us π/4. Next, to get rid of the inverse, we can do the sine, the function will cancel the inverse if it exists. And it exists inside of π/4 is square root of 2/2. Yeah, so that's what we have. Right? Yeah, so once again, the function cancel the inverse if it exists. Inverse cancel the function only on some certain domain. Right. Most important to know this kind of problem. Guarantee that you will see this kind of problem on the test. Right. Find the exact values of sine of tangent inverse of 1/3. Now, regardless of whatever it is, when we take tangent and inverse, that will give us an angle, right? So that's what we start with. Let theta be the inverse function in sine. So let's start with that. Let theta be what? Tangent inverse of 1/3. Now, how can we get rid of the inverse? The function will cancel the inverse if it exists. So take tangent on both sides. That cancel out, and we have 1/3. So tangent is 1/3, right? Okay. Now, after that, we can draw the triangle. Even though we use triangle, we should use x, y, and r here. Now, what is the ratio for tangent? Is that equal to y/x? Right? Yes. In that case, we let y equal to 1. Y is the vertical distance. And x equal to 3. Because of that, we can find r equals square root of x squared plus y squared. R is always positive. And so that gives us square root of x squared plus y squared square root of 10. Now, so we have x squared, y, and r. Now notice we did let tangent inverse to be theta, right? So this we just have sine of theta. And what is the ratio for sine? Would be 1/r, right? Would be 1/r. So that's what we have. Right. Now, can the calculator do that? Okay. since we have the function and inverse, let's keep this in radian. Sine of tangent inverse of 1/3. Right, so we have that. So how about 1 divided by square root of 3, square root of 10, sorry. Yeah, see, that should be the same. But should be able to do this by hand though. Right, we have a lot of example here. First, we let theta be the angle inside. Theta be the sine inverse of -1/2. Right, how do we get rid of the inverse? The function will cancel the inverse if it exists. That cancel out. Of course, that equal to -1/2. Now, what is the ratio for sine? Well, sine is y/r. So if we draw a triangle, theta, we know y is going to be equal to -1 because r is always positive, so we let r equal to 2. So we just need to solve for x. So how do we solve for x? Well, Pythagorean theorem. X squared plus y squared equal to r squared. X squared, don't know. Y squared, which is 1. R squared, 2 squared. So x squared is equal to 3. So x equal to plus or minus square root of 3. Now we go back to our problem. Cosine of sine inverse of -1/2. Sine inverse of -1/2. We have cosine of theta, which is x/r. So if x is equal to plus or minus square root of 3, then the question is that going to be positive or is that going to be negative? Well, so plus or minus square root of 3 over r2. So that's positive or negative? Now, think about this. The sine inverse, remember, has to be between quadrant 1 and quadrant 2. Cosine of quadrant 1 and quadrant 2. Is that positive or negative? Sorry, 1 and 4, right? Now, that positive or negative? Now, to answer that question, let's look at this. We have cosine inverse, cosine of sine inverse of -1/2. Now, this is in quadrant 1 or quadrant 4. Regardless of whatever it is, cosine of quadrant 1 and quadrant 4 is going to be positive. Remember, own store, take cash, the quadrant 4 cosine is going to be positive. Right, so it's going to be positive, so it's going to be positive. Yeah, so just that. Right, next. Find exact values of, by the way, if we're not sure about that, we can just say cosine of sine of -0.5. Sorry, the inverse, right? Right. Now, is that equal to square root of 3/2? Yeah, so it is positive, and the value is that. Right, so hope now you get the routine, right? First we let theta equal to the inverse trig function. Then in order to cancel the inverse, we need to take the same function. The function cancel the inverse if it exists. Cancel out -1/3. Right, ratio of cosine x over r. Remember, r is always positive, so we draw a triangle. X is -1 and r is equal to 3. And now we just solve for y. -1 square plus y square r square 3 square. So y square is equal to 8. So y equal to plus or minus square root of 8. By the way, square root of 8 is like square root of 4 times square root of 2. Or we have 2 square root of 2. Right, so we have y. Now we'll go back to the trig function. Right. Tangent cosine inverse is theta. So we have tangent of theta. Tangent is y over x. So this will equal to what? It's plus or minus, sorry. Plus or minus 2 square root of 2 or just square root of 8. I set by 2 square of 2. Y over x was x, -1. So the answer is it positive or negative? 2 square root of 2. Well, see if the calculator knows that. Tangent of cosine inverse -1/3. Alright, so that is negative. Right, how do we know it's negative? Think about this. All we do is just cosine inverse of -1/3. Let's do that first. That is quadrant 2. Right, cosine inverse how do we know if it is in quadrant 2? Well, if you give it in the degrees, it might be easier to see. Right, 109 degrees. So that is in quadrant 2, right? Quadrant 2. Now, if we have a tangent of a quadrant 2, is that positive or negative? Right. Only store typecast. In the second quadrant, only sine and cosecant are positive. So tangent is not. So tangent is negative. So it will be negative. Right. Actually, when in here, we actually can do this too. We can say sine inverse of -1/2. It is in quadrant 4. But cosine quadrant 4 is still positive. Right. So to determine the positive or negative, we just do the inside first, determine what quadrant is that, and then evaluate, determine if the whole thing is positive or negative. This case happens to be negative. Right. The other inverse trigonometric function. secant inverse, cosecant inverse, cotangent inverse we define the same way with the domain range. We will do the summary later. But now, let's find about what is cosecant inverse of 2. So how do we do that? Well, let's see, if we don't know what it is equal to, let that equal to x or theta. And then how do we get rid of the inverse? The function cancel the inverse if it exists. I don't know how many times I say that, but not the last. Cosecant cancel the cosecant, so 2. Alright, so that's good. Now what is cosecant? Remember, the reason we have to do this because the calculator doesn't give us the secant, cosecant and cotangent inverse, so we have to do it like this. Right, cosecant is that 1 over sine, right? Now cross multiply 2 sine theta equal to 1. And then divide by 2. Now sine is equal to 1/2. Right, so what theta is equal to? Right, sine 1/2, that will be 30 degrees. Of course, you can do the inverse also. Right, so cosecant inverse of 2 is pi over 6. Right, simple enough. Similarly, we do the same thing for the next problem. If we don't know what it is, make it equal to theta. And the function cancel the inverse if it exists. Right, now cotangent is equal to 1 over tangent. The reason we write like that, so the calculator can do the inverse of tangent. Right, so cross multiply square root of 3 tangent of theta equal to 1. So tangent of theta is 1 over square root of 3. So if we want to get back to theta, we can just say the inverse. Inverse tangent, this is 30 degrees. 1 over square root of 3. Yeah, so 30 degrees or pi over 6. Right. So that's what we have to do when we have the inverse sine, inverse secant, cosecant or cotangent, because the calculator does not do that directly, so we have to write this form. Right, now talking about calculator, how do we do this in the calculator? Well, similarly as before. If we don't know what it is, make that equal to theta and then cancel the secant. So 8 equal to secant. Secant is 1 over cosine. So almost either we cross multiply or we just flip both sides. So cosine is equal to 1 over 8. So theta is cosine inverse of 1/8. Now this we want it is in radian, round to 2 decimal places. Radian. cosine inverse of 1 over 8. So that is 1.45, 2 decimal places in radian. Right. Next, how to do cosecant inverse of -2? Well, same thing. If we don't know what the inverse equal to, make that equal to an angle theta, and then we'll cancel the cosecant inverse. The function cancel the inverse if it is defined. So -2 equal to cosecant, which is 1 over sine. Now flip both sides. So sine equal to -1/2, and we just solve for theta, so sine inverse. In the next section, this might not be true, but for now it will. For now it is true. Sine inverse of -0.5 or 1/2 is -5.52. We want 2 decimal places, so that's all we have. Right. Cotangent inverse of 1/5. Of course, we do exactly like what we have here. So, yeah, just going to skip this part. It should be simple. Just exactly like what we have been doing. Right. Now, I'll write cosine of cotangent inverse of u as an algebraic expression containing u. Well, kind of like what we've been doing. Let theta be the inverse trig function. Right. Right. Take a guess. What is the next step? Of course, I don't know how many times I say it. The function cancel the inverse if it is defined. So to cancel here, and we have u, which is u over 1. Let's write that as the fraction. Right. What is the ratio for cotangent? Cotangent is 1 over tangent. Tangent is y over x. So this is x over y, because this is cotangent. Tangent is y over x, cotangent is x over y. So in this case, we'll let x equal to u and y equal to 1. So I have x equal to u and y equal to 1. In that case, we can find r. Good thing for r is always positive, right? X squared, u squared, y 1 squared, or just 1. Now with that, we can go back to the problem. Cosine of cotangent inverse of u. Cotangent inverse of u is just theta. So I have cosine of theta. Cosine, what is the ratio for cosine? X over r. And what is x? Well, u. And then r square root of u squared plus 1. Right, so just like that. Yeah, cosine is x over r, and cotangent x over y, and then of course just trig function. Same thing here. First we will let theta equal to the inverse trig function, because the inverse trig function will give us an angle. Right, one last time, the function cancel the inverse if it is defined. Okay, u over 3. Now the ratio for tangent is y over x. Then we can draw a triangle. Y is equal to u. X is equal to 3. We can solve for r easily. X is 3 squared, so it will be 9, and y will be u squared. So sine of tangent inverse of u over 3, tangent inverse of u over 3 is theta. Sine is y over r, y, which is u, over r, 9 plus u squared. Right, so it simple enough, right? So we'll let the inverse trig function equal to theta, then try to simplify that, get either 2 out of the x, y, and r, draw a triangle to find the remaining one, and we can find the last one. Right. To finish the section, we're going to summarize everything in the table in terms of the domain and range. In terms of domain and range, there will be only a few types of answer here. So I try to write in color code. For sine, cosine inverse, sine inverse and cosine inverse, the domain is -1 to 1. These two will be the same. If I draw the number line between -1 and 1. We just go back and look at on the note. Now, tangent inverse and cotangent inverse. The domain be all real numbers. If we draw a line, it will be the whole line. And then cosecant and cosecant, secant and cosecant inverse. Right. So that is for tangent, cotangent inverse. Secant and cosecant inverse, this is what we have. However, I'm going to write that differently so you have a better idea of what it is. So what we have is a number line. But it is outside of -1 and 1. So -infinity to -1, union 1 to infinity, -infinity to -1, and then 1 to infinity. So pretty much everything except between -1 and 1. So it's outside of -1 and 1. The whole line and between -1 and 1. So those are the domain and range. The domain of those 6 trigonometric inverse trigonometric function. Now, how about the range? Now, even less than that, in the range, there's only two possibilities. Sine x, we did say that it is in quadrant 1 and quadrant 4. So, which means negative pi over 2 to pi over 2. And then the cosine inverse. Well, I don't have any color differently, so actually this one in orange. Quadrant 1 and quadrant 2 for cosine, meaning from 0 and 2 pi. Next, tangent inverse and cotangent inverse. One at a time. Tangent inverse. Still quadrant 1 and quadrant 4. But what is different for the tangent inverse? Right. Negative pi over 2 and pi over 2, but there's no endpoint. So quadrant 1 and quadrant 4. There's no endpoint though. So it would be like that, but it would be negative pi over 2 and pi over 2. No endpoint. No endpoints. Cotangent inverse will be quadrant 1 and quadrant 2, but no endpoint. So for tangent and cotangent, we don't have the endpoint. So instead of 0 to pi inclusively, it would be 0 to pi without the endpoint. And then secant and cosecant inverse. Cosecant is 1 over sine. Cosecant is 1 over sine, so that would be similar to here. I still quadrant 1 and quadrant 4. This is cosecant inverse, quadrant 1, quadrant 4, but we don't have y equal to 0. So we have that, but no midpoint. Which means we have exactly like that, but no midpoint. Meaning from negative pi over 2 to 0, we skip the midpoint, which is 0, and then we go from 0 to pi over 2. And finally, for secant inverse will be similar to cosine, also in quadrant 1, quadrant 2. And there's no midpoint. So cosecant and secant inverse, there's no midpoint. Actually, just one midpoint. There are two endpoints, but one midpoint. So it will be exactly like that, except there's no midpoint. So we go from 0 to pi over 2, which is the midpoint. Then union pi over 2 to pi. Right. So those are the domains and range of 6 inverse trigonometric functions. Right, so that's what we have in this section. So again, this is just the review in trigonometry. So most important, we need to know that the domain and range, because I will say that one more time. The function cancel the inverse if it is defined. The inverse cancel the function only in the domain. So we have to know that it have to be in the domain for it to cancel the function. Right. With that, I stop the video here. As always, thank you for watching, and see you in another video in pre-calculus.